Thanks very much, Terry. This is Eric Higgs here, and
Mary Sanseverino.
so a pleasure to be with you today, and thank you so much for joining us. I want to begin with some acknowledgements, and acknowledgements are always critical to what we want to do. We'll first of all to thank all of you, but also to acknowledge that our work takes place on traditional territories of First Nations across the Mountain West. The photographs that we deal with, the historic photographs, are often taken during a time of early settlement and colonization, and our aim in part with our Mountain Legacy project is to address some of that and to contribute to reconciliation. I'm also very grateful to the many people, collaborators at universities, at agencies in Alberta and British Columbia and the Yukon, the federal government, some of the sponsors that you see on the slide today, as well as volunteers who have helped us so much with photo identification and work in the field. And I want a special shout out to Julie Fortin and Maya Fredrickson, two graduate students who are working with us. So today, I'm going to pick up the first part of the presentation and then hand it over to Mary. She's the brains behind the operation, so she will explain some of the work that we're doing with image analysis. But first, we want to just give a quick introduction to the Mountain Legacy project for those of you who may not be familiar with it. Talk about our role in the Landscapes in Motion project, which is a project that is connected with Healthy Landscapes. To describe some of the software that unlock the secrets of the Mountain Legacy images. And then finally, to look at three particular applications of the work that we've been developing recently. So let's turn to the Mountain Legacy project and just give you a snapshot of what we're about. So we have four main components in the work that we do. It all starts with archival research. None of our work would be possible without some of the original images. And we're blessed by the world's largest collection of systematic historical mountain images. A lot of our work has taken place with the long-term support and collaboration of Library and Archives Canada, our national archives, and we've been working with the vast collection of glass plate negatives there. So we digitize those photographs and we go out into the field and retake those photographs. And we make all of that available to anyone who wants to use them through our various web portals. And I'll come to that in a few moments. But I just want to highlight that our images are big, both the historic and the repeat ones, so about 1.3 gigabytes per image pair. So we are dealing with what can be described as a computationally demanding project in terms of serving out resources. A lot of our resources get served out through something called Mountain Legacy Explorer, which is a website that spatially locates all of the imagery that we have. And to give some sense of numbers, right now we have about 8,000 image pairs distributed mostly along the spine of the Rockies from the US border north past Wilmore. So it's heavily focused on Alberta at the moment, thanks in large measure to the generous support of Alberta Agriculture and Forestry. Now we take those historical images and we go out into the field, and we have adventures of various kinds to take historic images such as this one. I think everyone will recognize this Athabasca Glacier. This is what Arthur Wheeler saw when he was there in, help me out, Mary, 1917. So it's changed a bit, as you know. And so our images tell powerful stories about landscape change, and that's what we're in particular focused on. The historic images were taken by intrepid land surveyors who used photography as a they were the only group really in the world to use photography as a technique for creating topographic maps. And so the Mountain West in Canada was mapped using photography. That's why we have so many images available to us. We've gone back into the field to repeat these images, to painstakingly locate particular places using various contrivances to find ourselves and our field crews in remarkable locations to take these images. Now, my focus has been on research and applying that research in meaningful ways. And so we've been, I'm just going to give you a quick taste of this because Mary's going to go into it more deeply. But we're interested in seeing what stories these images can tell. And so we have been doing lots of work in segmenting and classifying these images, using computer techniques to generate virtual images, draping photography over top of these virtual images. And all of this is happening through custom software we've developed called the Image Analysis Toolkit, which we'll get into a little more later. And then we've been, as one tends to do in universities, is trying to get this, the results of this out to a wider scientific and management crowd. And we do that not only through publications, but through various types of networking, through our mountainlegacy.ca website, the Explorer website I mentioned, our own blog, blogs with the Landscape in Motion project, features on photography websites, this one from Lens Culture last year, a recent article in Discover magazine, and so on. So our aim is to move to create a widespread platform of image data for people to use for various purposes. And we're blessed because we have this internationally distinctive collection. They're comprehensive. They cover most of the mountain regions in Canada. They're systematic. There's 120,000 of them, so they're really throughout the landscape. They're high resolution. Historic ones come off large format glass plate negatives, and then we do medium format digital repeats, so our images are high quality. And I know it sounds a bit strange to say this, but our repeat images have worked hard to match the quality of the historics. The historics are really superb. And then we have time depth, which is what perhaps the most intriguing part of this. Our earliest images are from 1888, and we have thousands, tens of thousands of images long before aerial photography became part of it. So we are able to see what the mountain landscapes looked like at a much earlier time than previously possible, and also at a really critical time in a lot of the mountain areas where it was the early days of resource extraction, the early days of settlement, the early days of displacement of Indigenous peoples and Indigenous practices, and so on. So the images are quite poignant in that way. Now today we want to connect in to some of the original Landscape in Motion, the LIM, we'll use that acronym, that we set out to 4 years ago when the Landscapes in Motion project first began. Our component, so how we tied in, was to look at how we would do image rectification. So take our oblique images, we'll talk more about that, and make them suitable for analysis in geographic information systems. We wanted to create a suite of software tools for visualization, and then we wanted to provide research management and decision support. Now, in the early days of our work with LIM, we were searching for the right image tools to work with. And one of them was pioneered by LIM collaborator Chris Stockdale, who did remarkable work in his PhD at the University of Alberta with software developed in Switzerland called WSL Monoplot. And he was able to georectify images. And that software offers a lot of capability. We were interested in something a little different, and we wanted to see if there was a parallel development path that would get us to the kind of the same place, but with some different features. We wanted sort of an end-to-end workflow for our unique collections of images. We wanted to make the this tool really widely accessible to anyone who wanted to use it, not necessarily those who had sophisticated technical capacities. We wanted to work with the strengths of the oblique images rather than converting them immediately to rectified images. And we also wanted to work with the finest resolution that we could muster from our images. So the monoplotting was a tool that Chris has used very effectively, continues to use. I think it's an excellent tool for certain kinds of applications. We're going to talk now, I'm going to turn it over to Mary to speak about some of the development work that we've done.
Thanks very much, Eric. And thank you to everybody for coming and having us here. As Eric's noted, the historic and modern photo pairs in the MLP collection have been used by researchers and mountain studies practitioners from a wide range of disciplines, all the way from ecological restoration to glaciologists. We've had anthropologists use them. We've used, and all of these, of course, many of these areas have been in our own studies here at Mountain Legacy. And we go on: forest ecology, wildlife ecology, wildfire management, wildfire ecology. And so stepping from that, I want to mention what for me probably, but generally for the project, has been the burning question that's informed much of the work we do at MLP, certainly the work that I do. What kind of visualization tools will help researchers and practitioners explore, interpret, and discover meaning in the photos, in the images? And we've developed software workflow, as Eric's mentioned, the MLP's Image Analysis Toolkit suite that helps us visualize this change starting from a human eye view. And you saw, we have visualizations just like you just saw here. We have fades, we have sweeps side to side, we have scaling, zooming, but there are many different ways to discover change in our images. And here's one of them. Here's one of the other things that the toolkit seeks to help us do, and that is to classify the landscape and gather some simple statistics on what we see. Now, of course, numbers are important, but really a visualization of these images, especially a visualization from a human eye viewpoint, really helps pop out the differences and similarities that helps us see what's changed and what hasn't, and where to and what from, and what it's changed into and what from. So let's take a slightly closer look at this. This is the Wheeler 1913 image of the classic Mount Assiniboine. We're looking, that's right on the border between, we're in BC and we're looking right to the border with Alberta there. And we see that Wheeler's had a spectacular day that he took this image, and we've classified this, and I'm interested to see that it's a fairly diverse landscape. But let's look at what happens when we look at the image in 2017. Again, this is the classified image taken from the same location. Notice how the dense coniferous forest has really infilled. I'm interested in that. So I'd like to be able to explore that a little bit further. Well, the toolkit allows that sort of thing. And here, what we're seeing is a union of dense conifer classifications between 1913 and 2017. And we can see that it was 11% in 1913 and a little over 40% in 2017. And here we see the join of it, the union of it. Now, this is fascinating, but I really want to see, I want to visualize, and I'd like to have some quantitative data on what the change was in the photos from 2017 to 1913, back to 1913. So we see that that dark green, 11% of the category, is unchanged. The bright green, 10.7, is dense conifer in 2017. Well, it was open conifer in 1913. About 8% is dense conifer in 2017, and it was herbaceous in 1913. So these are the kinds of visualizations and simple quantification that the Image Analysis Toolkit assists with. But what about on the ground extent? So now let's rocket over the range that we were just looking at. Let's head about 65 kilometers due east above the banks of the Elbow River, above beautiful Elbow Falls, and take a look at the area inside that yellow kind of triangle that you see. This image is, or this area was photographed by Arthur Wheeler in 1897, and there's the viewpoint looking into that triangle, 1897, and then repeated by Mountain Legacy in 2014. So you can see, oh, there's some change on this landscape. Here's the classification applied to it, and we've done a percentage of what's similar, what's changed, where that's happened in the photo itself. But we're still not quite on the ground yet. So how do we get onto the ground? Well, we take what we see in that oblique image and we geo-rectify it so that it becomes an oblique. Oh, pardon me. We go from the oblique image, geo-rectify it so that it becomes an orthographic image, so that we can do things like, and this, by the way, is that what you're looking at is the Wheeler 1897 landscape over that South Quirk area. And here's the fade in to the MLP 2014. I'll go back and show that just one more time. So here's the landscape, 1897. And here's the same landscape classification. And this is the Viewshed that we're able to see from that photograph and how it's changed. And because we know that the digital elevation model that underlays this is a 2-meter DEM, so that's 2 meters by 2 meters per pixel, we can also calculate things like actual hectare cover. So in 1897, in the image that we've looked at, we have a little over 1,200 hectares in conifer and a little over 300 hectares in herbaceous. And in 2014, well, we've almost doubled our conifer and we've come down to a little over 130 hectares of herbaceous. So let's do a little bit of a deep dive, unpack this, and see, how do we get to this point? So we're going to do this using a little bit of the work that we've been pleased to collaborate with Cameron Nafasi. And Dr. Nafasi is a researcher with Landscape in Motion Fire Regime team, and he reached out to the Mountain Legacy team to see if there were any historic images looking into his fire regime study areas. And together, we identified 20 historic images of interest, and thus far, MLP researchers have been able to classify 17 of them. So the hashed areas that you see on the image in front of you are Cameron's study areas. The camera stations are in pink. And what we'd like to do now is dive into the area to look at images from the southern part of Cameron's study area. So here we are, southern part of the study area. We're south of that South Quirk that we looked at just a moment ago, and we are in the Sheep River drainage, above it, looking down into the Sheep River drainage. And you can see that we've got two images that we're going to look at here, one from Nichols, 1916, and the other one from Parlee, 1940. So what do those images that cover this area look like? Well, there's the Nichols, and there's the Parlee, and there's the study areas. So these are Dr. Nafasi's study areas, and here is an initial classification. This is just a vegetation classification. Just let's note here how in this vegetation classification, it's a little bit more simplified than some of the more complex ones, for example, the Assiniboine one that I showed. And we are particularly interested in the conifer, mixed wood, and broadleaf. So that's the green, yellow, and red classifications, and to a certain extent, the purple, which is the burned. But the green, yellow, and red, with Dr. Nafasi, what we did was work to come up with two different ways to do this classification. So we did the really simple, straightforward vegetation class. And then for the conifers, the mixed wood, and the broadleaf, we did classifications based on density. And you see that to the left of the screen there in the green percentage categories. And then we further, for those same tree species classes, classified by height, tall and short, and 4 meters approximately was the cutoff. And again, you can see, yes, we're well into, got some good data in Cameron's study area. And we can even dig a little bit deeper here. So let's explore. So here's just looking at the 1916 image. So there's our classifications for vegetation. Here's the classifications for density of the 3 tree classes. And here's the classification for height of the 3 tree classes. We can even dig deeper. In this case, what we're doing is we're just splitting out, we're looking just at the conifer. So here's all of the conifer class that we see. Here's the density of conifer. And here's the height of the conifer. So all of this, I should want to point out at this juncture, we haven't gone out to a GIS yet or to do any ortho rectification or anything like that. We're strictly working within the images, and there's a lot of value within the images themselves. But nice to get out there to do a little ortho rectification of those oblique images too. How do we do this? Well, we start off with a good digital elevation model. As I mentioned, our DEMs that we're working with are 2-meter DEMs. Create a hillshade view for that DEM, and then add things like, what's the camera location and elevation? What's the azimuth? That's the direction that the camera is looking. What is the field of view? So how wide a field of view does the camera have? We take these and put them together in our image analysis toolkit, and we're using a depth tool on this, and we create a geo-referenced image. So the geo-referenced image is really kind of our bridge between the DEM and our historic imagery. In this case, we've got our 1916 Nichols photo, we've got our virtual photo, we're back in Image Analysis Toolkit, and we are going to make sure that the historic image fits within the virtual photo. You can see the orange outline on the virtual photo there. We always like to have a little tiny bit of extra area in case we have to adjust the historic image. We have control points that we put into place between the two. So there's our control point pair 1, 2, 3, and 4. With 4 control points, we're able to do a perspective translation to yield an image that is now aligned, the historic image now aligned with the virtual photo. Here's a slightly better look at it. So there's the virtual photo, and here's the historic image overlaid on it. So you can see it's a pretty nice alignment. Now we can apply the same transformation to the vegetation classification mask. So at this point, we now have a vegetation classification mask that we can apply to our digital elevation model. And the way we can do that is through the bridge that the virtual photo makes. And this gives us our ortho-rectified viewshed. And again, we've done this all in the image analysis toolkit using the depth tool. Now we're gonna, first time so far, we're gonna spread out and we're gonna show you this. This view is ortho-rectified view of what we're just looking at. And I did this one in QGIS. So we've now overlaid the viewshed, which you see in color, from the camera location, and this is the Nichols image. The light blue that you see is viewshed that we did not classify in this image. And so there it is with that unclassified material gone. And just for kicks and grins, here it is laid over a 2016 orthographic projection from Google. And a different sort of visualization on this, so semi-oblique. And again, we see the land cover laid out over our hillshade. And just to point out here, this 2016 Google Earth ortho rectify or ortho image, this is looking at land cover from 2016. This, and this is always just sort of blows my mind, we've now just laid a land cover classification from 100 years earlier onto that landscape. So look at the change now. We're looking at change on the land 100 years in the past. And so what did that landscape look like? Well, this is just the one image that we did the Viewshed on, but this one station has 3 more images. We could cover the entire area with just this 1916 imagery. But there are a lot more images that we could use. So every pin that you see on this little map that's in front of you, and again, this is looking down into the Sheep River drainage, could be used to create, if you will, an atlas of change in this area, and it extends pretty much up and down the spine of the Rockies in Alberta, an atlas of change in areas that people might find of interest. And so with that, I'm going to turn it back to Eric to take a look at a few more items around change and change detection.
Great, thanks very much, Mary. I want to go back to the deep past of the work that we've been doing that Mary described, and that's taking it back 4 years. So to the work of Julie Fortin, who was a very talented master's student who worked with us and is now a research manager at the University of British Columbia. Julie can't join us today, but she's here in spirit. She did her master's project in the early stages of the work we did with limb. And so her study area was not actually down in the limb study area in Southwest Alberta, but actually up in Wilmore. And so she tested out some of the early ideas that we were trying to apply. And I want to speak a little bit about that. She wants to emphasize in her work that when you take repeat photographs of the same landscape, it allows the human eye to visualize slow changes that happen over the span of decades. And so we make up, when we present our images, where we want to be able to show how powerful it is to see the landscape from the human eye perspective. Here's another one from Wilmore, in which you can take a look at the shifting vegetation patterns that are quite striking on the landscape. So what Julie did was what Mary described as the sort of, we'll call it simple quantification. So she classified the images and overlaid these masks on the images to get a sense of what the nature of the change was. And we can, when we do this for pairs of images, we can look in terms of relative photograph area, so not on the ground, but relative photograph area of the nature of those changes. She computed those to look at mean historical land cover and mean contemporary land cover to get a sense of how this was shifting. One of the things she noted, as did Janine Remtula in an earlier publication using some of these techniques in Jasper National Park, was that there's an eerie correlation between relative photograph area, the classes in relative photograph area, and what we see when we actually georectify and look at those same classes. But Julie's interest was in seeing changes in biodiversity over time. And so what Julie looked at was a biodiversity survey in Wilmore that had contemporary biodiversity data for a guild of songbird species. And from those were developed habitat suitability models for each of those species. She then went back into the historical images and interpolated what you would expect the likely habitat suitability was in the past and compared those to the present, with some striking results in terms of which bird species. I'm not going to go into detail today, and she has an article forthcoming on this, but there's it's really striking to see that some species did pretty well in the past. Some are doing okay in the future, some are not doing so well. So getting a sense of the changing landscape and how it's favoring some species over others. And Julie was at the time wanting to dive into this georectification tool, but our master's thesis came to an end just before we were able to get to it. But out of her work came this, and I want to give a shout out, and I believe this is attached to the presentation if you're interested in pursuing it. a publication in recently on estimating land cover composition from oblique images, and in it is a really strong and fascinating defense of the power of oblique images and how they show certain features that orthographic projections do not. So check that out if you're interested. We're in the home stretch. Let me just turn to one last case study and then wrap up. This is work that's about to begin and is going to be focusing in the landscapes in motion study area, so near K Country in southwest Alberta. This is graduate student Maya Fredrickson, who will, over the next year and a half, be looking at historic Indigenous fire patterns. Her interest has been to take what we know from the literature about the ways in which Indigenous peoples manage the landscape. And out of work by Hank Lewis and Teresa Ferguson years ago, we knew that there were yards and corridors and connectivity in the landscape that were created. We're just using, this is just as an example, this image. So what Maya's work is going to be doing is looking at some of the literature in terms of what it says are likely ways in which the landscape was managed for fire, using fire. And then to be able to model out in the landscape how that's changed over time. And so she's going to be looking, she's consulting with First Nations, working collaboratively with dendrochronology data, and laying this all out with some of the spatial signatures of these patterns. She'll be using the image analysis toolkit for this particular project, and she just demoed some of what this could look like in the future if we look in the green at some of the so-called yards, areas that might have been kept open for particular purposes, and then corridors that may have shown areas in which people were moving through the landscape. So this is speculative work. I'm just presenting this as sort of where we want to go. There's certainly a profound and elevated interest in how historic land management might have kept forest communities a little more open and reduce catastrophic wildfire risk. In wrapping up, let's speak about what's next for where we want to go, specifically around the outcomes of the landscape and motions work we've been doing. The first is, no surprise, we're working on a publication that documents the sort of the end-to-end oblique image analysis. And we're hoping to get that out in the not too distant future. We're ongoing development of software to help people be able to unlock these images. We're also in a research and applied management setting, wanting to focus on integration with two powerful open source software tools that are becoming kind of like the primary tools that we're using. Many of you are probably using these as well, but the suite of statistical packages known as R and QGIS. So we're working on that. And then finally, we're sort of looking at, well, what can we do more with the limb study area and what kind of analyses can we perform going forward? So that's our so where we're thinking of going. So let me, on behalf of Mary, wrap up and thank you very much for being with us today, and look forward to your questions and happy to carry on conversation. Drop us a note if you're interested in aspects of the project and you'd like to know more. Thanks again.
Thanks, everybody.